So for today's lesson, I'm just going to quickly revise the empirical rule, which I was doing with you before the Easter holidays. And then I'm going to go on and do confidence intervals with you. So as you know, you'll be having your in-class assessment on Thursday. And that will be on statistics and probability. So I will go over everything with you for the next 3 days before your exam. So don't worry about that. All right. So the empirical rule is where we were looking at data, so a normal distribution. So basically all data, most data falls into a very similar pattern, okay? And it's where the mean, the median and the mode tend to be around the middle values, okay? So your middle values here is where the mean is. So things that fall into normal distribution would be height, weight, exam results, length of time spent watching TV, anything really that a lot of people would do would fit a normal distribution, okay? So if you remember from before Easter, we have here is our normal distribution shape. So we have our middle value here, which is called our mean, all right? So we'd say a lot of our data lies around the mean. So over years and years and years of studying, they have found that actually within the mean, within one standard deviation of the mean, plus and minus one standard deviation of the mean, 68% of all your data will lie there. Okay, so they found that that has been proven over and over again, that in things which follow a normal distribution, 68% of people in the data that you have collected should lie within one plus or minus one standard deviation of the mean, okay? So standard deviation is how different something is from the mean, and you calculate that. I would have shown you how to calculate that on your calculator before the Easter holidays. So we've further found that 95% of all data will lie within plus and minus 2 standard deviations of the mean. Okay, so that means that if you surveyed 100 people, so if you surveyed 100 people about their weight, 95% of those people would be within plus and minus 2 standard deviations of that mean. And if you surveyed 100 people, you would find that 99.7% of all people would fall within plus and minus 3 standard deviations of the mean. Okay, so if we were talking about out here, and we were talking about height, we would say that somebody out here would be very, very tall, an outlier, and someone over here would be very, very small from the data that was collected. Okay, so it's very important that you know 68%, you know 95%, and you know 99.7%. Okay, so we went over all of that before the Easter holidays. So those figures I can't overestimate for your exam and for your Leaving Cert how important they are. So when we break those down further then, okay, so the 68%, so here's the mean, here's the average value that you might be given or that you might be asked to calculate, okay? So 68% can be divided into obviously 34 and 34, okay? Then we push out to the 95%, so that will split the parts into 13.5, 34, 34 and 13.5. And then when we push out to incorporate 3 standard deviations of the mean, those parts are 2.35% and 2.35%. Okay, so if I got a question like this, so this question came up on the Leaving Cert 2020. Okay, so a typical way you could be asked the question. So you definitely need your calculator for this, okay? So it says an aptitude test was taken by 6,500 candidates. The test scores were normally distributed. The mean score was 480 and the standard deviation was 90. On the distribution below, show the shaded area represents all candidates who were within 1 standard deviation of the mean, and write down the value of A and the value of B in the boxes below. So here you can see this is your normal distribution. So you should be thinking of your empirical rule straight away, okay? So this is the mean. This is minus 1 plus 1 standard deviation of the mean. This is minus 2 plus 2 standard deviations of the mean. And this is minus 3 plus 3 standard deviations of the mean. Okay, so this is plus and minus 1. So it's going to be 480 minus 90, which is going to be 390. and it's going to be 480 plus 90, which is going to be 570. Okay, so what that means is we would expect 68% of the people to score between 390 out and 570. So 68% of the people we would expect to score between that. Okay, so plus and minus 1 standard deviation of the mean. All right, part 2, so that's part done. Part 2 says use the empirical rule to estimate the number of candidates in the shaded region. So because you've recognized that that's the empirical rule, we know that 68% of people, we would expect 68% of people to score within that range. Okay, so you will say 6,500 multiplied by 68%. You'll put that into your calculator, and your answer turns out to be equal to 4,420. So you would expect that 4,420 candidates would score between 390 and 570 in their exam. Okay, so again, cannot overestimate the importance of 68, 95, 99.7. So if we look at this question here, in a survey, the IQ scores of 1,200 people were recorded. The mean score was 100 points, and the standard deviation was 15 points. Assuming that IQ scores are normally distributed, the data are shown on the diagram below. Fill in the missing numbers on the horizontal axis. Okay, so start with what the mean is. So we can see that the mean is 100. And the standard deviation is 15. So it's going to be 100 minus 85, or 15, which is 85, which is already done for you, and plus 15, which is 115. Then it's going to be plus, so that represents the 68%. Then it's going to be plus or minus 2 standard deviations of the mean. So it's going to be another 15 added on. So it's going to be 130, and it's going to be 70. And then for 3 standard deviations, it's going to be 145, and it's going to be 55. So my empirical rule tells me that 68% of people will have an IQ between 85 and 115. 95% of people will have an IQ between 70 and 130. And 99.7 people will have an IQ between 55 and 145. Okay, so the majority of the population, of the people that were recorded, would fit between 99.7% of those people would fit between an IQ of 55 and 145. A person is chosen at random from those surveyed. Use the empirical rule to find the probability that this person has an IQ score between 70 and 130 points. Okay, so I'm just going to divide up my diagram here again. Okay, so we know that that's 68%, so I'm going to call that 34 and 34. Okay, we know that between here and here is 95. Okay, so 95 take away 68, and if I go back to this here again, I can see, oh, that leaves me with 27% there. So I'm going to be, that's 13.5%, and that there is 13.5%. So look at what the question said. The question said, use the empirical rule to find the probability that this person has a score between 70 and 130 points, okay? So it's going to be 13.5 plus 34 plus 34 plus 13.5%. Or you can see that it's within 2 standard deviations of the mean, so that's 95%. And in terms of probability, we just call that 0.95. Okay. Part 3, use the empirical rule to find the approximate number of people surveyed with an IQ score of between 85 and 115 points. So this is what I'm looking from here, between 85 and 115 points. So that's within 1 standard deviation of the mean. So it's 34 plus 34, so it's 68%. Which is, so we want to find the number of people. So it's going to be, there was 1,200 people surveyed, multiplied by 68%. So 1,200 multiplied by 68% is equal to 816. So we would expect 816 people to have an IQ between 85 and 115 points. Okay, so that's the way the questions on the empirical rule comes up on your leaving cert, and it'll be something quite similar on your exam on Thursday as well. All right, so again, can't overestimate the importance of 68, 95, 99.7. That will help you to answer the majority of your questions. Okay. So what we're going to start on now today, and I'm going to go over with you, is confidence intervals, okay? So confidence intervals is about where we gather data and we are able to make statements about the data, okay? Now, so the first thing we're going to look at is margin of error, all right? And I spoke to you about this before the Easter holidays. So whenever we collect data, obviously, unless we can interview the whole population, so basically if I wanted to find out how all the Leaving Certs in Ireland felt about what happened this year with their Leaving Cert, I could try and interview every single student who is doing their Leaving Cert, but obviously that would be very time consuming, very costly, and it would take me a long time to do it. So I wouldn't do the population, I would take a sample of the population. But because I don't do the population, obviously my data is going to have errors. All right, so I have to look at, I have to be able to account for the errors. So if I'm asked to calculate the margin of error, you have to look at the size of the sample that you surveyed. So for instance, if I only survey 20 people, to calculate margin of error, it's 1 over root n. Okay, so you have to remember that. So if I only sample 20 people, my margin of error is going to be quite large. Okay, so I'd put into my calculator 1 over root 20, and it tells me that's equal to 0.2236, which is actually 22.36%, which is a large margin of error. So I would expect that my data would be inaccurate by 22%. If I surveyed 1,000 people, it would be 1 over the square root of 1,000. So because my sample is getting bigger now, I would expect that my margin of error is getting smaller. So that's equal to 0.031622. So actually my margin of error there is 3.16%. So I've increased my sample size from 20 to 1,000, so therefore I now have a margin of error of 3.16%. So that's definitely getting closer. If you want your data to be reliable, you need your margin of error to be smaller. Okay, so just one more there to show you the difference. So if I actually surveyed or interviewed 10,000 people, just to see what my margin of error is, it's 1 over the square root of 10,000, which is equal to 0.01, which is 1%. So if I surveyed 10,000 people, I would only have a margin of error of 1%. Okay, so obviously the more I survey, the more reliable my data is, and the more reliable my confidence intervals that I can make, that I can say. So a confidence interval is, and you will do it for 95% confidence interval. So with a 95% confidence interval, you can say that you are 95% confident that the data lies within plus or minus the mean plus or minus the margin of error. So if you wanted 99% confidence, or if you wanted 80% confidence, it would be more, so it's one margin of error. So it would be more margin of errors, less margin of errors, and so on. Okay, so I'm going to start by doing a question with you. Okay, so I'm going to start with question 1 from exercise 14.7 on your book. Okay, so a manufacturer of computer components wishes to estimate the proportion P of its present stock of components that are defective. So they've done a random sample of 500 parts. Okay, so they're going to check and see out of those 500 parts how many of them are defective. And they actually find that 10 are defective. Okay, so they want us to construct a 95% confidence interval for P, the proportion of all components that are defective. So lots of information here. So first of all, the sample size is 500, so that's going to be important for us. when they carried out their survey, they found that 10 out of the 500 were defective. So for you to get the proportion that are defective, okay, so the proportion that were defective, so that's just P with a hat in it, the proportion that were defective was 10 out of 500, which is equal to 0.02. So they found that the probability of something being defective was 0.02, which is 2%, a 2% chance that they were defective. Okay. So I then want to create my confidence interval. For me to do my confidence interval, I need to know what my margin of error is. So remember, for margin of error, it's 1 over the size of the sample that you surveyed. So in this case, it was 1 over the square root of 500. So 1 over the square root of 500 is equal to 0.04472, and it goes on and on, okay? So you have a margin of error, you would expect to have a margin of error of 0.04472, which is 4.47. I'm just going to round to 2 decimal places. So there is a chance that your data will be wrong by plus and minus 4.47. Okay, so you want to create your confidence intervals. So your confidence interval is going to be made up of 2 plus or minus 4.47. Okay, so 2 minus 4.47, so 2 minus 4.47 is equal to minus 2.47. Okay, 2 plus 4.47 is equal to 6.47. Okay, so your margin of error is going to be equal to minus 2.47 less than or equal to the mean, less than or equal to 6.47. So we could say with 95% confidence that between minus 2.47 and 6.47% of all products sampled would be defective. So that we would say that the maximum, we would say that we are 95% confident. So we're not 100% confident. We're 95% confident that the max number of products that are defective are 6.47, and that the minimum number of products are minus 2.47, and that's percentage. Okay, so if so in this case here, we were told that there was a sample of 500 products. So we would expect that 500 multiplied by 6.47 percent, we would expect that 32.35 of those would be defective of the 500. So we're 95% confident that only 32.35 of them would be defective. So I'm not 100% confident. I'm 95% confident. All right, but it's giving it would be used to give companies something to work with, something to aim for and work towards. All right. So the next question I'm going to look at now is I'm going to look at question 2. All right. So question 2 on your book says a bank randomly selected 120 customers with savings accounts and found that 90 of them also had check accounts. Construct a 95% confidence interval for the true proportion of savings accounts customers who also have check accounts. Okay, so first of all, there was 120 customers. So 120 customers, they is the size of their sample. And they found that 90 of them have checking and savings. So that's basically 90 out of the 120 have a checkings and savings account. Okay. Quickly write that down. All right. So the proportion of the population of the survey that they have completed. So 90 out of 120. So that's equal to 3/4, which is equal to 75%. So 75% of people in the survey that they done, they believe they know have a checkings and savings account. So we want to expand that out now to the population. So we want to say, well, at a 95% confidence interval, what is the maximum and the minimum amount of people who could possibly have a checkings and a savings account? Okay, so we have found that our population proportion, we have found that we would expect 75% of people to have a checkings and savings account. So we have to calculate our margin of error. So our margin of error is equal to 1 over root n, and in this case we surveyed 120 people, so it's 1 over root 120. Now, so 1 over root 120, which is equal to 0.09128, etc. and it goes on, all right? So I'm just going to round that to 9%. Okay, so because I've only surveyed 120 people or bank accounts, my margin of error is going to be quite large, so it's 9%. So I want to create now my 95% confidence interval. So it's going to be 75% plus or minus 9%. Okay, so it's going to be 75 plus 9, so 75 plus 9 is equal to 84, and it's going to be 75 minus 9, which is equal to 66. So I can create a 95% confidence interval by taking these two end values and saying 66 is less than or equal to the mean, less than or equal to 84. I would expect that I can say to you now with 95% confidence that 66, I would expect that the lowest number of people that would have a banking and savings account, a current and savings account, would be 66%, and that the highest amount of people that I would expect to have a current and savings account is 84%. Okay, so out of my 120 customers, I would say with 95% confidence. So if I was to expand that out then to 10,000 customers. So at 10,000 customers, I would expect the max amount of them to have a current and a savings account would be 8,400, and the minimum amount of 10,000 customers that I would expect to have a current and savings account would be 6,600 euros. Okay, so that's confidence intervals. So the empirical rule is a separate topic to confidence intervals. So with confidence intervals, you have to find, what is the mean, or what is the population proportion, what is the margin of error, and plus and minus that. Okay, so now I want you to do, into your copybook, I want you to do exercise 14.7, questions 3 to 6. Okay, and I will upload that onto Schoology as well.